Hello, so welcome to another video. So today I'm going to be going over the build of my bead roller, which I've been wanting to do for a long time. Been in the market to buy a bead roller for quite a few years, but just never managed to get there. Didn't want to buy a cheap one, and the ones that I really like, most of them are in America, are out of my price range, and then trying to ship one over from the States would be probably crazy money. So I've been collecting parts and bits and pieces with the intention to build one over the past few years, and sort of got to the stage where I've got a few projects coming up which I could really use the machine. So have just slowly started to put the machine together, and decided just to do a bit of a video, show you where I'm at. It's going to be take me a few months to probably to get this thing properly together, but we'll do a few videos in maybe a few parts, and hopefully we'll have a working machine in the next few months. So I had this this three-phase motor here. This is brand new. It's a Tico brand. I've had it for a few years, just been knocking around under the bench and gathering dust. So I thought this would be the perfect motor to start with. It's a three-phase motor, and three-phase offers a lot more capability over a single-phase motor. You get a lot more torque. It's easier to control a three-phase motor, to set it up to do reverse, start, stop, and all that sort of stuff. Lots more controllability. So I've kept that, but it originally had this gearbox on it. Not sure if you can see the spec of it, but it's the ratio there. I'm not sure if you can read that. It's a 10-to-1 ratio. So I thought that was not going to be able to run the bead roller as slow as I want. So obviously, with the bead roller, you don't want to be running it too fast. I'm no expert, but I figured the slower the better. So I jumped online and did some research, and I've just bought this. This is the Chinese version of the gearbox here. It's I mean, they're a standard frame, so if this gearbox ever gives away, also I didn't pay much money for it. It was cheap, a couple $100. But this one is this one's 80-to-1. The same frame you can get in 100-to-1, so it's a little bit of suck it and see, I guess. I'll see how the machine runs, and if it's still running too fast, or if it's not got enough torque, I can always upgrade that to the 100-to-1 ratio gearbox. Not expensive. Okay, so as I said, this is it's a three-phase motor, but you can control that with a variable frequency drive, which is what I have here. This one is just second hand. I bought it off of, I think, Facebook Marketplace. I didn't pay much for it. It's a good brand one. You can buy these brand new from China, but they're you know, I don't know how reliable they are, and I'd rather get a decent one. So this is, again, this is a Tico brand one, so it's a known brand. Should be nice and reliable. Now this is a single phase one. You can get these in a three-phase to three-phase, but single phase 240 volt for me is what I wanted to do. So and with these controllers you can set all sorts of variables. So excuse me, you can change the speed that the motor is running at. You can change the way, like the up ramp, down ramp. You can change all sorts of stuff. So I set this one, just run it now. So that's full speed at the moment. So if you set it running, so that's way too fast for a bead roller, but we've got the variable speed control here. So I can get that to come right down, right down. I mean, that's barely moving, so hopefully that's lots of control for a bead roller. Obviously, these buttons here are not going to be able to use while the machine's running, so you can run these remotely. So I'll hopefully have a variable speed foot switch, which I'll use to power this. So the foot switch should be a variable, so I can run that at full speed with the controller. If you notice, when you press the stop, I'll set this up so that when you press the stop, it stops dead. And when it runs, I'll set the ramp up speed very, very slowly. So I thought that would work good for a bead roller. So you can change speed with it as well. I'll go back the other way. Happy days. So that's where we're at with that. So basically I started this project, this is all I had. So basically I jumped onto AutoCAD and measured up the flange here for the gearbox, and basically went from there. So we'll jump over to my computer and I'll show you roughly how I started to rough this out in my head. Okay, so here we are on my computer. Hopefully you can see what I've got here. I'll zoom in a little bit. All right. So basically, I started off by drawing up a flange to mate up with that gearbox. So this is the flange I've designed here. These red circles are the mounting points to get the gearbox bolted up, and these 4 small ones here are for the spigot ring. So the gearbox itself has a mounting spigot on it, so my plan was to get this ring bolted up here, and that will locate that properly. This one here is just a side view. It's shown with it's an assembly drawing, just showing the spigot ring mounted, how it's going to sort of sit. From there, I then was just messing around here with the different gears, and I want the top shaft to be able to slide left and right. So this is just showing the positions of the gears fully backwards in the green. Not sure if you can see that. Black in the middle, and then the light blue coloured with the gears fully forward. So from there, excuse me, I then went to an assembly drawing. So I'm just zooming in a little bit. So we've got the motor here. Here's the gearbox. Here's the mounting flange. So from there, I then went through and designed the main frame size. So I'm just going to go through this very quickly. So the slot here, which you can see, it's for going to be for adjusting the top shaft, so I can slide backwards and forwards. That outer window there is going to be for assembly, so that'll be to access the gears. Tighten up the grub screws, putting it all together, all that sort of thing. And then as we come forward, you can see the 2 bushings for the front. So the bottom one I'm going to have bolt in, so that's permanently mounted. But I'm going to have it bolt on, sorry, so it can still be removed for maintenance if I need to change the bearings. And the top one here, this also has to pivot up and down. So there's a little bit of engineering going into it. Obviously, as the top shaft moves up and down, these gears are going to get marginally closer together and further apart, so you've got to make some allowance for that. And so once I've done that assembly drawing, I then went into individual components. So here we've got, this is the top bearing for the top shaft at the back. So I've got some fossil bronze bushings which I'm waiting to get made up. That's all fairly self-explanatory. We've got that's the main bushing there. This is obviously a welded component, so this is the bottom piece. Yeah, what else we got? This is the front bushing, so you can see the 2 threaded joints. It's just a through. The diameter there is just a through diameter, 28, to suit a fossil bronze bushing. It's basically simple stuff, and then I went through and designed the shafts. So they're going to be keyed at the back to suit the motor, and then I've got circlips to hold that in position. And then at the front of the shaft again, 2 more circlips here. This is where the bearing housing is going to sit. Circlips are going to hold that, stop that from moving around. That's basically it. So that's kind of where I started off. I had all these components here machined up at a machine shop. I don't have a lathe or a mill at the moment. Would love to have some, but currently I don't have it. So these gears, just going back to the gears, obviously because the gears on these are going to be the main working component. So I found a really good website, Ronson Gears. I hope this is still video. So this is their website. It's obviously in Australia. So if you come up to the menu button here, you come down to stock gears. And just scroll down, they've got all various different types of gears that you can buy from this company. Really good website here. But also we're going to go with spur gears. And then you come down to gear catalogue here. And I've got either a PDF catalogue which you can download. You can order a hard copy apparently. But I just went on the online catalogue. And then you go through to spur gears again. So on the left here, you've got all your selections, so you can choose the material that you would like it to be made out of. So we're going to pick steel. Not too concerned with the other stuff here at the moment. So our bore diameter, so our shaft diameter, I'm going to go with a 25mm shaft, which is there. I want a high precision teeth with a keyway, and this comes up with your selection so far. So, and the other one we need to go is our pitch diameter. So the pitch diameter, when you're building a bead roller, it needs to be relative to the size of the bead roller wheels you're going to be using on the end of the machine. So you want the two shafts to be as parallel as possible, so the gears are meshed nicely. So we're going to choose 66, which is what I personally chose, and then scrolling up, we've got two options here. So they're different gears, so you can go through and you select which one you want to have a look at, and it comes up with a drawing. So this was the particular gear I went for, and the reason I went for this gear was this 30mm dimension. So the bigger that dimension is, this will allow the two gears to mesh with each other, and obviously because the top gear needs to slide in and out of the machine, so the bigger that dimension, the more adjustability you're going to get in the machine. Now, I'll explain that a little bit more when we get outside. So that's basically how I went about it. These gears, they weren't available in Australia. I had to get them made in Japan, or ordered from Japan, and they got them shipped over. Really good service from Armstrong Gears. Highly recommend them. Brilliant. Right, we'll head back outside, and I'll show you the gears, and we'll go from there. So basically, after I'd done all the drawings, I had a local machine shop machine all the bits and pieces up. So they made me the shafts, they put the keyways in, and they made me up the blocks. So basically, as I was saying, when these when you get the machine together, these gears obviously have to mesh, and you want these two shafts to be as parallel to each other as possible. Obviously, if you've got your two wheels, whichever you're going to run, you don't want them to be like this. You know, you want it nice and parallel. So basically, when you're choosing what gears to run, you need to choose the diameter as close to probably the bigger wheels that you're going to be running on your machine. So that's kind of where I've got. These are what's that? 63.5, 64, which is 2.5 inch in diameter. So you go on that onto Ronson's website, and you choose the gears which have got that same pitch. So that's basically where that happened. So the bearing blocks I've chose to just made out of normal mild steel. You can see, just zoom in there. You can see there's the bushings I've chose. So those bushings that's a normal off-the-shelf component. If you go to a normal bearing shop, you can buy these in all different lengths. They're quite thin in the wall, so it makes it good for machining components. There's different bearing linings. This one's a graphite material in there. I'm not sure exactly what that one is. Someone else may know better than me. But these are really good. They last a long time. They're really good for high loadings. Perfect choice for a bead roller. So they just push in. You do need probably a press to push them in without damaging them. They are split, so they'll close up as they go in. So that goes on the shaft, and you know they spin nicely, and there's no play. They're good, perfect choice. So that's my bottom shaft and the top shaft. Similar setup, but I've got some phosphor bronze washers there, and that's held in place with some circlips. Now at the moment the shafts are I've left them long. I'm not sure how I'm going to set up the ends just yet. Done a bit of research on the internet and looked at other people's designs, and I'm not totally decided 100% what I'm going to do there yet. I guess the other thing with the gears is they're keyed, and they also have a grub screw, but I don't like relying on grub screws. They can tend to move around a little bit, so I've put on some shaft collars. So these shaft collars come from a company here called Roland. I'm not sure how you pronounce that. Off the shelf part, nice and cheap. That's what I've done. So you may notice I've changed the design slightly from what I saw on the AutoCAD design there. I just put in a round piece and welded that on. So that's going to be for our adjuster. So I'll get this stuff out of the way and I'll show you the main frame. So this is my main frame. So the reason I chose to show the video now is because at the moment it's open, so I don't have the side plate in place and welded off. Once that's on, you won't be able to see internally, so I thought this would be a good opportunity just to show you how it's kind of going so far. So pretty much everything here is 10mm thick plate. That's 3/8 for you in the States. I had the rear plates here laser cut. The spigot ring has been laser cut, and as you remember from the drawing, that's just bolted in place. It's big, it's heavy, it's over engineered, but that's kind of got my name all over it. I just think if you're going to under engineer something, it's you know, the second that it goes wrong, then you've got to basically start again. So I over engineer everything. I like to have lots of weight and mass in something like this, because I think if you're using a bead roller, you don't want the machine to be moving around and vibrating on you, all that sort of rubbish. So I've just over engineered the hell out of it. Just lay it down. It's got a bit of weight to it. There we go. Okay, so I just laid it down here now. So you can see I've put in all this reinforcing. I'm not sure if it's going to need it. I think the 10mm plate and the other 10mm plate on top is probably going to be plenty of rigidity, but again, it adds weight to it, adds mass to it. And once the outer sheet is on top and welded off, obviously I can't then add this afterwards, so it's either a now or not at all kind of thing. And I just thought, for the cost of whacking some extra steel in there, I think it's worth the potential gain. So I've just done that. So I've just welded it off and made triangles, nice strong shape. So we'll assemble this together, and hopefully you can sort of see how it's kind of coming together. Hopefully, maybe. So basically, the bottom shaft, bear with, not done this for a while. It's going to sit in there. Not sure if you can see on camera. I've got the two mounting holes here. I've got bolt holes down here. These are threaded, so that'll be bolted in from there. So I'll do that now, and I'll just speed the camera up. The other thing you might notice here, I've got some cutouts here. The gears were thicker than what I had sort of envisaged in my design, so I've had to put a bit of relief in there, just diagram that out. I think I use a finger sander, to be honest. Alright, so that goes there. I'm just going to put some bolts in there, and I'll be back. Hang on. So that's basically that's how the gearbox, motor gearbox is going to mount, and the bottom shaft's in. I've got a little bit of scalloped out metal there, not sure if you can see that, that's so that collar can sit there. The window here is obviously accessibility for lubrication and to assemble the machine, take it apart, all that sort of stuff. So as I said before, I don't trust the grub screws on these gears. They can move around, you know, with a bit of vibration, and in time the grub screws wear out. So these collars, they're a great addition. So I've got one in front here, and I'll probably put one in behind. I'll just show you how they work. So again, these are made by Ruland. This is or Roland, I don't know how to pronounce that. So I screw this one out, and it's a split collar. That obviously goes in on one side, it goes on top. Let's see if I can drop this on the floor. There we go. That's basically it. They're a brilliant thing, and that'll lock that gear. That will never move. Well, hopefully that will never move. So the top shaft, again, I've had to put a cutout here. This allows the split collar to move in a little bit more clearance. This slot is for adjusting the position of the top shaft as well. So that's basically hopefully going to sit somewhere in there like that. That slot will allow that to move backwards and forwards. And as I said, the wider the length of the gear here means you got the more adjustment you're going to be able to have. So that's going to that's basically how that's going to work. So I'll just adjust this so I can get a bolt in from the back, and then we'll turn this on and I'll show you it in operation. Okay, so that's basically the top shaft's fitted. I've put the bolt underneath. That gives us their maximum throw forward and backwards. Obviously I would like to engage that as much as possible, and if I can adjust it from the front, I'll go down that road and leave those fully engaged. So the things you've got to make sure of when you're designing one of these is that the shaft can move up and down and those gears still stay meshed. So there's a little bit of engineering making sure you don't get those gears to bind up or be too loose. That's basically kind of where I'm at the moment, so I'll just show you roughly what's going on here. So that's full speed. And you can still move the gear, move the top shaft, sorry, up and down. And it's still meshing okay. How slow can I get it to run? You're not going to want to run any slower than that. I mean, that's got lots of controllability for me. If you're doing fine turns with the bead roller, you need to have lots of control, lots of slow speed. And there's plenty of talk in that. I mean, I've obviously be different with the actual rolls and the but I mean, if I hold it away, I can't slow that down. It's got lots of torque. I can't stop it. There's no way, no. So hopefully that'll be okay. I mean, I guess it's a little bit of suck it and see. As I said before, if it works out there's not enough torque, I can change that gearbox to a 100 to 1 ratio, and that will give me 20% more torque than what I've got now. It's a beautiful thing. It goes back in reverse again, and it stops dead. I figured a stop dead would be the way to go. I can change this to when you stop it, it ramps down slowly, but I figured if you're bead rolling a fine design and you want to do some sudden changes or you need to do a correction, I think a sudden stop might be the way to go. I mean, we can change it, we can program this to do whatever we want. So I'm looking forward to seeing how it works. So basically, the next thing I'm going to be doing is put in, I've got another whole side plate, another 10mm plate to go right over top of all this. Things I've got to be wary of is that this doesn't bind up. So when the plate sits on top, this needs to have, I don't know, 0.1, 0.2mm of clearance. And again, the same with the front block, that needs to have clearance. So that can allow that to move up and down. And I also do want a little bit of clearance for this so that I can take that out, so that I'll be able to undo the bolts and slide it out the front. That's basically where I'm at with this design. I'm pretty happy with it. It's going to be a decent size. I think the spoke I've got, the wheels are going to be, I'm not sure 100% where if I'm going to put those out here or in here. But I mean, that gives me 750mm, that's 30 inches roughly. That will do a full sheet. So I'm hoping it's going to be big enough. So that's what I'm up to at this stage. I'm pretty happy with the progress. I'm interested to see how it's going to come out when we put the sheet on top. We'll see how we go. It should be a good thing. It should be a good addition to the workshop, and got some projects coming up that I'm going to need this machine, so we'll be making as much progress as I can over the next weeks, month, two. Thanks for watching, and if you haven't done so already, please hit the subscribe button. We've got some videos coming up of current works in the workshop. The skyline is it's been a backwards and a forwards project, but it's coming along good. So this coming week is going to be a good week. We're into putting the seals back in and all that sort of stuff. So lots going on, and yeah, keep watching, and thank you for supporting this channel, and we'll see you soon.